All right, so modeling. Again, we want to make sure that we say let x equal something or whatever variable you want to use, and then we're going to try to write a system and solve it. Really, any method is up to you. So it says that a person rows a boat upstream from one point on a river to another point 4 miles away in 1.5 hours. The return trip, traveling with the current, takes only 45 minutes. So if you're going with the current, it's going to be a little bit quicker because the water is going in that same direction. How fast do they row relative to the water, and at what speed is the current flowing? Okay, so first we really have two things here. X is going to be our rowing speed in miles an hour. And I don't know why not, is going to be our current speed. The current, like speed, the water current, not like presently. Current as in like how fast the water is moving. All right, so from here, what we want to do is figure out what does this really look like? Well, we know a few things. We know that the distance traveled is going to be the same each time, okay? We also know that distance is equal to, speed is equal to distance over time. And since we know what distance is, why don't we make this speed times time is equal to distance? That might make life a little bit easier since distance is going to be a constant number for us. It's 4 miles. All right, so one direction, our speed upstream times the time upstream is going to give us the distance traveled. So the speed upstream is going to be x minus y because you're working against the current. You're going to take your speed, but then you're going slower because the current's kind of going the opposite direction. So we have x x minus y, that's my speed upstream, times the time it takes. So upstream, it says is 1.5 hours, or it might be easier to just do 3 over 2. And that equals 4 miles. The other one we have is x plus y, and that is going to be 45 minutes, so that's 3/4 of an hour. And again, that's going to give us 4 miles. So the current helps us when we're going with the current, and when we're going upstream, the current hurts us. All right, so let's distribute that number to both of these. Actually, you know what might be easier is let's multiply to get rid of the fraction entirely. Let's start with that. So if we multiply both sides by 2 and both sides here by 4, then I don't have to worry about fractions at all. So that's going to give me x minus y times 3 is equal to 8, and we have x minus y times also 3 is equal to 16. Okay, and let's distribute that 3. So we get, I'm just going to write it over here, I'm running out of space, 3x minus 3y equals 8, and I have 3x plus 3y is equal to 16. All right, the y's are ready to cancel, so let's add down. That gives me 6x is equal to 24. So x is equal to 4. So my rowing speed is 24. That's part of the answer that I want. I also want the current speed. So I can go back into any of these equations and plug it in. It does not really matter here. It's up to you. So I don't know. Why don't we use this equation? Why not? So 3 times 4 plus 3y is equal to 16. So that's 12 plus 3y is equal to 16. Which gives us 3y is equal to 4. So y is going to equal 4/3. So that's 1 1/3 miles per hour. Okay. Lastly, a school is selling tickets to an annual dance competition. On the first day of ticket sales, the school sold 4 adult tickets and 9 child tickets for a total of $129. The school took in $171 on the second day by selling 12 adult and 3 child. What's the price of one adult and the price of one child? So let's let A equal the price of one adult ticket. And how about C for child? You could use X and Y though. Okay. So in the first day, 4 adult tickets, so 4 times the cost of an adult plus 9 times the cost of a child is going to equal $129. On the second day, 12 times the cost of an adult plus 3 times the cost of a child is going to equal $171. Okay. And now we just want to get these to cancel out. It's up to you what you want to do here. We do want to know both information, so it doesn't matter which we cancel out. I guess let's just multiply by, how about -3? And that's going to make sure that the C's cancel out. So we have 4A plus 9C equals 129. And we have -36A minus 9C is equal to, let's see, 171 times -3 is going to be -513. All right, so the C's cancel. That's -32A is equal to -384. And then we're going to divide by 32, so we get that A is equal to 12. So that means that there were $12 for each adult ticket. And then we have to plug that into either equation, it does not matter, to find out child ticket costs. So 4 times 12 plus 9C is equal to 129. 48 plus 9C is equal to 129. 129 minus the 48 gives us 81. So when we divide, we get $9 for a child's ticket, which usually makes sense for the child to cost a little less.